Hello viewers, welcome back to my channel. This is Ranjiraj and you're streaming on the Study Beast. So in today's video, we'll be solving a problem based on the Tower of Hanoi in artificial intelligence. So it's a very easy problem. There is no particular algorithms or steps to solve this problem, but it's based on trial and error, not error, but basically you need to understand the situation and just solve the problem. So this is the big problem where the Tower of Hanoi problem that starts. So the problem reads like this: somewhere near Hanoi. So Hanoi is a place in Vietnam. It is the capital city of Vietnam. So it is a capital. So just forget about that. So somewhere near Hanoi, there is a monastery whose monks devote their lives to a very important task. Now let us see what this task actually is. So in their courtyard, there are three tall posts. On these posts, there is a set of 64 discs, each with a hole at its center and of different radius. When the monastery was established, all the discs were on the one of the post, each disc resting on the one just larger than it. The monk's task is to move all of the discs to one of the other pegs. Only one disc may be moved at a time and all the other discs may be on one of the other pages. In addition, at no time during the process may a disk be placed on top of a smaller disk. The third peg can, of course, be used as a temporary resting place for the disk. Now, you have to formulate what is the quickest way out of this for the monks to accomplish their mission. So this is the overall problem of Tower of Hanoi. So you would be giving a tower like this where there would be, so this entire thing represents a tower. This is the base and this is the altitude or the height, in fact we can say, and this 3 2 1 are the pegs or steps, you can say, in fact. So in Tower of Hanoi this is more pronounced as pegs. So uh, so uh, according to this, you can move only one peg at a time, and at a time one can rest on, means until you will reach the final stage, you have to move in such a way that only two pegs can rest on top of that, and the two, it should be in such a way that it should be in this order, like two can rest on three, one can rest on two, or one can rest on three. It cannot be in this way, like if you have three here, you can rest two. So that's not the way it is done. So you need to be careful while solving this. So first of all, we have this one. So we have another post, and this is the third post. So at the very first move, what will we do is we move this peg 1 to here, and post 3 is empty. So now we again do this. So we have this much left, and this is 1 here. And now in this, what will we do is we move peg 2 here. So peg 2 will be like this. So here only 1 would be there, and here 2 would be there. Now at the next stage, we have to move one of the peg on top of that. Now our final configuration would be, or this is the initial configuration, then our final configuration would be at post 2 we would be keeping 3, 2 and 1. So this would be our or this could be a solution to this. There are n number of possible solutions to this. So let us first keep 3 as it is here, and just move, this will be kept as it is. So we'll just place 1 over this 2 on top of 2. So it would be like this. And then at the next move, what we do is we just move 3 to the post number 2. So it becomes like this, and this would be 1 here. And now what would we do is now we have to move to this position. So for that, what we do is we can move this peg, or in fact we can move 1 to this position, that is at the very first position we can move, and 3 just here, and just 2 here. And after this, what we can do is we can move 2 over top of this. So 3 on top of that 2, and remember I am moving only one peg at a time, and this remains empty, and so our final step would be this would be empty, and we would be moving one on top of this. So it would be 3, 2 and 1. So and this would be empty, nothing would be there here. So this is the final solution for this. Not final solution, you can have n number of solutions for this. Like we had this pegs in this manner here. So at the final step, we had 1, 2, 3, 4, 5, 6 and total 7 steps to achieve or to make the pegs to move to post number 2. So you can also move pegs to post number 3 or vice versa by taking n number of steps. So this was all about the Tower of Hanoi problem in artificial intelligence. So hope you enjoyed this video. Found this video helpful. Please hit the like button, and if you haven't subscribed to my channel, subscribe. Thanks for watching this video.